I'm going to start by telling you that I'm a bit of an outsider in this community. I only discovered that I have something possibly interesting to say about XML because XML is used a lot in lexicography. That's the discipline I work in. And when I say lexicography, I mean making dictionaries. And when I say dictionaries, I mean these things. Although these days, obviously, most people use dictionaries not in the form of printed books, but in the form of sort of digital tools, websites, mobile applications, and other things like that. So lexicography in the last, let's say, 2 decades has become very strongly digitized. And it has become digitized not only in the sense that people consume dictionaries digitally, but also in the way that we produce dictionaries. Typically we use specialized software for building dictionaries. We don't even talk about writing dictionaries. We talk about building them or compiling them semi-automatically from data. And so we use something called dictionary writing systems. And inside a dictionary writing system, the individual entries that constitute a dictionary are typically represented as small XML documents. And there's usually an XML schema and some schema formalism, such as XML schema, for constraining what the structure of these entries should be, and so on. So because of my engagement with lexicography and with how XML is used in lexicography, I've noticed a few things about how we tend to use XML in lexicography, which I think are slightly problematic and possibly sort of deserve attention outside the field. So that's why I'm here today, to sort of introduce to you what I think I have discovered about XML and how it fits the use cases that lexicography requires. By the way, everything I'm going to be saying today is basically a rehash of a paper I published recently in the journal Data and Knowledge Engineering. So you can look it up if you want to dive deeper into what I'm going to be saying. I'm going to repeat this slide at the end, so you can sort of copy the URL afterwards if you discover that you're interested. So as I said, in lexicography, we usually represent entries as small XML documents. And if you look at the type of XML that usually floats around in lexicography, it usually looks a little bit like this. So the names of the XML elements that we use are things like entries and senses and headwords and definitions and example sentences. So it's a fairly high level kind of domain specific markup, okay? This is not your typical text encoding scenario where you say that something is a paragraph and something is a bulleted list and something is a numbered list, okay? It's more abstract than that. This is kind of whether something is displayed as a paragraph or not, that comes from a style sheet later. So this is the kind of vocabulary that we usually use in lexicography. And if we look at a slightly more realistic example of a dictionary entry, a slightly larger dictionary entry from one dictionary that I've been working on, and then if you look at the XML that makes it happen behind the scenes, you will probably discover that the XML is pretty complex. It's quite difficult for human people to read. There are so many levels of embedding, okay? You have elements inside elements, inside elements, inside elements, inside other elements. So there's a lot of structural markup. I call this, this is a phenomenon that when I talk about it with my colleagues, I refer to it as the matryoshkization of XML schemas. You know the metaphor that this is based on. There are these wooden dolls, these Russian wooden dolls. If you open one, there's a smaller one inside, and then you open it and there's another smaller one inside there, and so on. It's a recursive toy. It's very good for teaching programming. But in lexicography, I think it's basically a bad practice if you have a lot of matryoshkization in your dictionaries. I've done some number crunching. If I sort of pretty print the XML like this so that it brings out the tree structure, and then I count the number of lines that contain actual human readable text or something that's going to be shown to end users as human readable text, and compare it to all the other lines, it comes out as a very unfavorable ratio of the majority of the code is actually sort of structural code, not actual human readable text. If instead of that, I count just the XML elements instead of every line of code, then of course the ratio becomes a bit more favorable, but it's still about 50-50. Okay, so about 50% of what somebody editing this XML sees on their screen is basically kind of structural clutter, which kind of gets in the way. I know it's there for a reason, it supplies the structure, but still the lexicographer is interested mainly in the text and not so much in the structure. So that's matryoshkization. And one comment I usually get at this point is people tell me, okay, yes, it's heavily matryoshkized and everything, and it's not very user-friendly, but of course you can build clever user interfaces, which hide this complexity from the human user. And of course, that's true in theory, but in practice, that's almost never done. Because in practice, dictionary writing systems usually look like this. A dictionary writing system is basically a glorified XML editor, where the human lexicographer is fully exposed to the complexity of the matryoshkization of the schema, of the many levels of embedding. Most dictionary projects don't really have the budget or the engineering power to sort of build specific user interfaces for their own specific dictionary schemas and keep them updated throughout the course of the project. So mostly they just acquire an off-the-shelf dictionary writing system, customize it with their own schema, and off they go. So lexicographers spend 8 hours a day staring into screens like this. So that's why I think it's important to consider matryoshkization seriously. Another before I go to other things, it basically boils down to the fact that notations matter, okay? If the notation is human-facing, which it is, then the notation you use is going to determine what people are able to do with it. And if it's so heavily matryoshkized that the human lexicographers are unable to understand where everything is and where everything should go, then that kind of makes their work difficult. So maybe we should think about it more seriously. Another problem where matryoshkization causes problems if you need to change the schema halfway through your project. So let's say you have designed your schema such that it allows you to have an element called translation somewhere in the entry, and this element contains text, and you encode, you create, let's say, 1,000, 2,000 entries which comply with the schema. And then management decides that they want to be able to change the schema so that you can associate different kinds of labels with the translations, part of speech labels, usage labels, and so on. So you change the schema like this, you matryoshkize it, okay? And what has now happened is that your pre-existing entries are now invalid. So you need to write a schema migration script in order to migrate the entries from the old schema into the new schema, to do something like this. Again, people might say that this is not necessarily a problem. Schema migration scripts are a common thing everywhere you have data. Okay, schema migrations happen all the time. But if you have to do schema migration every time you introduce a tiny little change into your schema, it kind of stands in the way of agile kind of practices, right? Ideally, you would like to be able to change your schema like this without having to change the underlying data, without invalidating your pre-existing data. So these are the reasons why I think that matryoshkization is a serious problem which we should think about. And now that we have established that, let's kind of dive deeper into the problem. Why does matryoshkization actually happen? It's not like it's a bad practice which we can agree to stop doing, okay? The matryoshkization happens for a reason. One design pattern that we often see in lexicographic XML is basically fragments of XML that look a bit like this, where you have a sequence of elements with different names, and you can look at them and you can say that one of them is kind of the head of the whole thing, and then the other ones basically just provide additional information about the head. And then the container is there just to group them together, okay? So this is the head. This could be, let's say, one of the many translations that are offered inside the dictionary entry. These are some additional information about it, such as it's part of speech labels, some usage labels, and so on, and this groups them together. Okay, so this is a pattern we see everywhere in lexicography, not only on translations, but on usage examples, collocations, and many other things. It's everywhere in lexicography. So the mental structure behind this is that it's a tree structure like this, where you have a head, which consists of something like a name and a value, and then you have a list of other pairs of names and values, which are kind of modifiers to this, okay? And if you want to model this in XML, if you want to represent this mental structure in XML, what are your options? Okay, let's say if you don't want to do matryoshkization, you don't want to have levels of embedding, what else can you do in XML? Well, of course, you can use XML attributes and do something like this so that the modifiers become attributes. And now it's a lot, let's say, easier to read for humans. But then, as you know, XML attributes have a bunch of inconvenient constraints. For example, if you want to have more than one of something, like more than one usage label, you can't really do that in XML, unless, well, not out of the box anyway. Or if you want to have some kind of inline markup inside some of these modifiers, you can't really do that with XML attributes either. So modifiers as attributes, that's not really a very good strategy. It doesn't scale, okay? You can turn it on its head, and you can decide that you're going to treat the head of the whole structure as an XML attribute and do something like this, okay? But then again, you run into the problem that there are certain things you can't do with XML attributes. So if you want to have any kind of inline markup and things like that in the head of the structure, then you can't really do that, okay, in XML. So this is not really a very good structure either. You can get away with it sometimes, but it doesn't scale. And one last thing you can do that would probably occur to you as an idea is that you can do mixed content. So you can declare, you can say, okay, we're going to just say that the first text element is like the head, and the first text node is the head of the whole thing, and then all the other elements are basically its modifiers. But that also becomes difficult if you want to have, let's say, inline markup or some kind of structure inside the head. Then it becomes difficult for the XML parser to even recognize where the head ends and then the modifiers begin and so on. So this is not ideal either, right? And it turns out that there really is no ideal way to represent this mental structure in XML. The only one that kind of doesn't bring with itself these trade-offs is the matryoshkization, right? Where you have child elements for everything. But that has other trade-offs, such as the fact that it makes the entries less easy to read and causes problems in schema migrations and so on. So there's really no ideal way. There's really no perfect way to model these things in XML. And I've spent a lot of time thinking about this problem and thinking about why is it? What is it about this mental structure that's so difficult to represent satisfactorily in XML? So I thought about it like this. If this is the mental structure I want to represent, what are its properties, right? It consists of a pair of a name and a value, which constitutes the head of the whole structure, and then a list of other names of pairs of names and values, which are their modifiers. So the ideal the ideal meta model to represent this in any kind of notation would be like a triple, like a group of three things, a name, a value, and a list of modifiers, which is basically a possibly empty list of other such triples. Okay, so this would be the ideal meta model for a language in which we could represent this. But in XML, everything is a tuple, not a triple, really. You know, everything is a group of two things, a name and some content. And the content could, of course, be something complex, like a list of nodes of different types, some of which are plain text, some of which are other elements, and so on. But it's always a group of two things, right? There's no way to distinguish formally inside the content whether something belongs to the head of the structure and something doesn't. So that's the reason why this mental structure is difficult to represent in XML. What about languages other than XML? Can we find a language where we can represent this headed structure sort of with more satisfaction than in XML? What about JSON? JSON is, of course, very popular, but when you and looks very different from XML in terms of its syntax. But if you look at the underlying meta model, you again come to the conclusion that in JSON, everything is a tuple, a group of two things, you know, a name and some content, a name and some content. And the content, again, could be a complex thing. It could be an object with other sort of children inside it. It could be an array, but it's always just one thing. Okay, so JSON, unfortunately, is out. It's not a good candidate either. What about YAML? YAML is very popular. It's it's very human friendly. It's like the Python of data. I love it, but unfortunately, again, when you look at YAML, you come to the conclusion that the meta model again is the same. It's based on tuples, not triples. So everything is a group of two things: a name and a value, a name and a value, or some other content, right? So again, it breaks my heart to say, but YAML is not a good candidate either. Now let's look at something slightly more of the beaten track. Let's look at SGML, XML's historical predecessor. SGML had some interesting features related to markup minimization, which I want to sort of look more closely at now. In SGML, people are mostly familiar with the fact that you can sometimes omit closing tags because the parser can figure out automatically from its knowledge of the schema that the closing tags should be there, and it can kind of assume them to be there, okay? So that's one kind of markup minimization feature of SGML that many people know about. Another markup minimization feature that people probably don't know much about in SGML is something called implicit elements. You can in the schema, you can say that some elements are implicit, and that means that they don't have to be explicitly marked up, but the parser will understand them as if the markup were there. So you can say in this kind of Matryoshka structure, you can say that the first child element there called value is implicit. And if you do that, then you can sort of, it doesn't have to be there, okay? So you can even have SGML like this, but the parser will understand it like this. So this is a feature which we can use. If anybody was still using SGML today, we could use this feature to introduce some kind of support for headed structures into our schemas, because we could design our schemas such that the first child element, the one which we consider the head, is implicit, so it doesn't have to be specifically marked up. And this would help us, for example, in the schema migration scenario. If you think back to the schema migration scenario that I was showing you, so let's say you have a schema that allows you to have an element like this somewhere, and it contains plain text, and you create a couple of entries that comply with the schema, and then you change the schema, you Matryoshkaize it, and you decide that instead of having translation text, you're going to have translation value text. But you're going to say that the value is going to be implicit, so it doesn't have to be specifically marked up. And this means that your old entries are still valid with respect to the new schema, so you don't have to write schema migration scripts. So these two things are interchangeable. Now, wouldn't it be wonderful if we could still have this today? I mean, of course, SGML still exists and everything, but you know, we use XML for encoding dictionaries, and XML is wonderful and everything, but it sort of doesn't allow us to represent these headed structures very well. So that's why we keep running into these difficulties. And if maybe we hadn't given these things up when everybody migrated from SGML into XML way before my time, we wouldn't be having these problems today. So this is the point where my presentation could conclude, but I want to sort of show you one more little thing. I work for a company called Lexical Computing. This is a company which, among other things, makes dictionaries, you know, builds dictionaries, and it uses kind of modern data-driven, agile, digital techniques for doing that. Everything is kind of semi-automated. So we need to change the schema often and things like that. So we often run into these difficulties, and we have been thinking about these limitations that XML and also JSON and YAML, all the other languages that they impose on us, with the Matryoshkization and everything, until we discovered that if you just take this mental structure that I have been showing you throughout the presentation, and if you take away the dotted lines, and if you just rely on indentation for structure, you end up with something which actually could be a formal language. So what we have done is we have actually formalized this into a formal language. We have given it a name. It's called name value hierarchy, NVH. We have written a specification for this, and we use this internally for representing our dictionaries, the dictionaries that we work with, right? So in name value hierarchy, a dictionary entry looks like this. So you can see that it's a hierarchy of name value pairs. That's where name value hierarchy comes from. If you compare a representation like this to what it probably would look like in XML, I think you will probably agree that the NVH one is kind of more human-friendly, human-readable, and more human-writable, because it's a language which is optimized for representing these headed structures that I was talking about. If people can have this, why would people settle for this? We certainly haven't. So this is name value hierarchy. You heard about it first. You heard about it here first. You can go to the website to read more about it. It's a language that has been designed specifically to support sort of these headed structures, which abound in lexicography. They are everywhere. It's probably the only discipline where they are present so much that it really, really gets in the way and causes our XML to be too complex. So that now is the end of my presentation. just let's summarize briefly what I have done, what we have just done together. So I've introduced you to a couple of concepts that I've kind of partially invented myself, such as matryoshkization and the concept of headedness in content, right? That sometimes you have name value pairs, and one of them is the head and the other ones are the modifiers, which would ideally be modeled as triples, but we can't really do that in XML. We can't do it in JSON either. We can't do it in YAML. We can kind of do it or fake doing it in SGML, but SGML has a lot of other trade-offs because it's difficult to write parsers for it and so on. And then I've introduced you to this new language that my colleagues and I have invented called NVH, which is actually optimized for doing this. So with that, thank you very much. And I'm looking forward to hearing your comments now.
Would you please stand up and raise your name?
Stephen Pemberton. It sounds to me like you need IXML.
Yes, definitely. Yeah. Of course. Yeah. So NVH could be implemented as, or something else could be optimized for simplifying the XML into human readable, something more human readable, obviously. Yeah.
I'm not very familiar with YAML, but it looks very much the same. What was the exact difference between YAML?
The main difference is that in YAML, you can't have something colon text and then underneath it again something colon text.
Okay, colon text is an end leaf.
Yes, exactly. Okay. Yeah.
Okay. Thank you.
So basically a node in NVH has two kinds of children. It has one value, which is plain text, and then it has kind of other children, which are other triples. Deliberately, NVH is designed to be very similar to YAML because we like it, but it has this one additional feature,